velocity of business is really accelerating. You used to compete with people or companies in your region or your country, but now it's global competition. And expectations of your stakeholders are higher than ever. You get new executives all the time with new strategies. Certainly mergers and acquisitions throw the company upside down. There's restructurings, reorgs, and then finally new technologies. The pace of the technological advancement today is incredible. So there's new opportunities with each new platform advance. So we've got mobile now, we've got cloud, we've got big data. So if the velocity of business is accelerating, we internally have to go as fast as possible. And we need IT, the data people, the apps people to lead that charge. Because if they're behind us, they're weighing us down, they're dragging us down. We want employees, we want to empower them with information at the point of interaction with customers, at the point decisions need to be made.
But even this looks sort of clean, right? Because for some end users, yeah, our IT systems look more like this. Right? Even more complex. I sometimes have the feeling that they think, yeah, we are going to build it like this, sort of straight on these production systems. But we all know that that's not going to work, right? We always build these chains of databases, right? Long chains of databases where we copy data from one database into another, into another, into another. And the closer we come to the right-hand side, yeah, the more the data has a structure that the user wants. And this is sort of a very simple picture of our chains. In normal cases, we have networks of databases, right? Multiple data marts, multiple personal data stores, and I'm not even adding operational data stores and whatever we have. But some of these architectures are highly complex. And more, my question is this the architecture for the coming years? And of course, it has helped us, has served us really well for the last 20 years, but is this still the right architecture for the coming years? And if you deploy data virtualization, say, well, let's first get rid of these data marts, physical data marts, yeah, and personal data stores, and just implement that in a virtual way. That definitely simplifies the whole architecture. And some customers have done exactly this. It makes it easier, it makes it simpler. Yeah, data virtualization is all about decoupling data consumers, such as reports and applications, from all the data stores, data warehouse, data marts, production databases. And if we decouple, it will become easier to plug in new data sources. I'll talk about that later on. It will be easier to implement new forms of BI, easier to replace storage solutions. Imagine you're playing around with an Oracle database engine or a SQL Server engine, and you want to have some more speed, and you want to move towards an appliance. If you decouple the reports from the databases, life is a little easier. So the moment you ask for data, then it's being integrated, then it's being transformed. And then what data governance people definitely like is the centralization of common data integration specifications, and I will get to that later on. But that will lead to better productivity maintenance. Einstein said everything should be made as simple as possible. Well, data virtualization helps with that, absolutely.
So with data virtualization, there's an opportunity to reduce our need for consolidating types of techniques, data warehouses, data marts, and also the people needed to implement those. I could be more agile, more proactive with data virtualization, and I need less people to manage the environment. Data managers should really think about implementing data virtualization first, data warehousing second. And that's a radical statement from a guy who spent 12 years as Director of Education and Research at the Data Warehousing Institute. And in the end, it makes you a partner with the business, and that's a much better place for you to be in. It's more exciting, it's more challenging, you get greater recognition, you have a better career path. So this is the way you want to go.
So I already used this diagram, which sort of shows data virtualization from 10 miles high. But now how does it really work? You import a table from Oracle, or you import a table from SQL Server, or a sequential file, or an Excel spreadsheet, or web service information. You sort of import those specifications so that the product knows that the data sources are there, and then the fun starts. Because then what you're going to do is you're going to define virtual tables. You're going to sort of add sort of specifications that will transform the original data in the data that you want to see. Is at the lower level of virtual tables, you can bring in all the cleansing operations, all the standardization of codes. Then on the second level, you can bring in integrations, so that if customer data is spread out over multiple sources, on that middle layer, you're going to bring it together. And then on the third, you're going to define virtual tables that have structures that fit the needs of the reports or the end users. So if you look at what we have to do to build a virtual data mart, it's very simple. What you have to do is design data structures, right? You still have to talk to users. What kind of information do you need? And then we have to define a mapping, which means we have to define how the data is going to be transformed from the original data into that virtual data mart structure. But that basically is it. If I compare that to building physical data marts, that's a lot more work. Then the guys doing report development can start. So much faster I can sort of deliver the report. It could of course be that what I've created, maybe it's not the fastest solution possible, but the users can play with the report, they can play with the data, and then afterwards, if necessary, I can always spend time on, okay, do I have features to optimize performance, to tune it, but the point is I can deliver the report much more quickly, and I think that's a big advantage of data virtualization. What you can do is bring in that specification at the data virtualization layer, just once. Now you can probably understand why data governance people like that. And this will just be one of the specifications that is part of the definition of the data virtualization layer. Plugging in new data sources is relatively easier to do. We don't have to build, again, these chains of databases to sort of massage that data from these new data sources into the right shape so that it fits with the other data. Well, we can do that virtually. We have been spending way too much time on technology. We should be spending more time on analytics and reporting and what the user wants. Self-service BI tools have done for the world of reporting, making it more agile, making it more self-service. That's sort of what data virtualization is doing for the data storage layer of your data warehouse architecture, making it more agile. It fits the world of self-service BI. One of the very practical advantages of data virtualization is that we can always look at the data itself. And that leads to a more collaborative form of development. We can sort of work together. And that speeds up the whole process. If you then also want to combine the operational data with historical data, which is probably inside the data warehouse, again with data virtualization, it's just a matter of sort of combining the two, sort of hooking them up to the data virtualization layer, and then presenting all that as a sort of a clean set of tables that hold the original up-to-date data and the historical data. All right, thank you, and I think we're going to go on way back.